Hey guys, thanks for coming along this evening. Today I'm going to be talking to you about scaling your JavaScript applications, or how to structure applications that are small, medium, and large in size. We're at a very interesting point in time. Back in 1999, ES3 first came out, and over the past 10 years, we've seen a huge increase in the efforts to try helping us structure our JavaScript apps just a little bit better. We've had Dojo, Sprout Core, which is now Ember.js, JavaScript MVC, Backbone, and a number of others. Now, JavaScript is no longer just being used to enhance the user experience on people's websites. It's being used to power complex web applications, and with this comes some greater concerns we have to think about. Things we didn't necessarily have to worry about with JavaScript when we were just using it as a toy language.
Things like internationalization, modularity, performance, scale. And all of these issues are things which we can probably solve using intelligent architectures. So architectures can help us build things that can properly scale, but you have to have the right architecture in place, and you have to understand what it means to come up with an architecture that can work for your project. Now, I know that we're not going to have a full room of hardcore JavaScript developers. Some people are going to be still using, jQuery for the most part, and that's okay. If you're, used to using jQuery, and that's probably, 50% of your job, you're going to get a lot out of this presentation. So first thing to remember is that jQuery plays a very, very small role in the overall architecture of medium to large scale applications. It's great at DOM manipulation, but that's pretty much where it stops. And there are lots of other concerns that you need to take care of and need to think about. jQuery doesn't provide you any ideas about how to structure your application. That's not, we're never going to do that. We're never going to tell people, we think you should do this better, and this is the right way. But thankfully there are a lot of solutions that we can use and leverage to help us solve this problem. And the first thing we're going to take a look at is how to organize your code. This is going to be a great section for people who are looking to structure code that may be in a spaghetti form at the moment, or may not be using any sort of structure to help break down concerns. We're first going to take a look at design patterns, and then we're going to move into some actual code. Now I know that, design patterns is something which you may not necessarily spend hours and hours reading about. It's not always the most exciting thing to go reading about. But I'm just going to try paring this down to the most important points. And I guarantee if you actually understand what I'm going to show you, you're going to be able to write your own version of Backbone.js, your own version of Ember, or any of those things. If I want to walk into a project and write my own MVC library, I can do it now because I understand the concepts I'm going to talk about. So architecture patterns help define the structure for applications. Does anybody want to take a guess at 2 or 3 different architecture patterns just off the top of their heads?
Modular passing?
Sorry?
Modular passing?
The modular pattern is technically not an architectural pattern, but yeah.
MVC?
MVC, yeah.
MVVM?
MVVM. Any more? Okay, cool. No, we're gonna go through the main ones. So we're gonna go through MVC in a little bit more detail very soon. But just to give you the highlights of it, MVC is all about sort of taking your application and putting concerns into different buckets. So every application is going to have a certain amount of data in it, and we're going to throw those into a data bucket. We're going to call those models. Then we have the presentation layer. We call those views. And then we have another layer generally called controllers. Now in JavaScript frameworks these days, you're usually not going to find a controller. I'm going to explain why quite soon. Controllers are usually there to take care of user input and things like that. Now something most people don't know is that the observer pattern, or pub/sub, which is what some of you may have used in the past in your JavaScript applications, is actually built into MVC. It's what enables it to do things like, if you have a view, so if you have a particular page and you want to watch a model, so that if something changes in that model, you're going to refresh the screen so people have the latest, most up-to-date data. So like if I had a photo gallery application and I maybe edited the metadata for a particular photograph, I want to make sure that when I sort of click away from that the current view is still displaying the most up-to-date data. And the observer pattern in MVC actually allows us to do this. Again, I'm going to go into this in more detail very soon. Then we have the model view presenter pattern. This is a pattern you probably won't see a lot of people actually forcibly trying to go implement in JavaScript, but it's very, very close to MVC. This is something that's used by a lot of people that are developing web frameworks. You'll probably see them using this when they're using perhaps ASP.NET or other frameworks like that. But in MVP, there's a slightly heavier focus on the UI. the presenter, the P part of MVP, plays the role of a controller, and the view here handles your sort of user input logic. This is a little bit similar to what's done in Backbone.js. I'm actually going to talk about how solutions like Backbone.js aren't using MVC very soon. Next we've got MVVM. Now if you like developing using data binding, so if you're currently looking at solutions like Knockout.js, for example, that's using the MVVM pattern. And data bindings mean that, MVVM is more about sort of placing the focus of the relationship between models and views. You don't care as much about the controller, you try shifting that logic back to the view. And again, this has a slightly different component to MVP and MVC. You've got a view model and that provides the data bindings. But its core idea is that it converts data from the model to something that the view is going to be able to read in. Some people like data bindings. It is possible to actually take existing JavaScript frameworks and modify them in such a way that you can use the MVVM pattern with that. But do spend some time actually investigating these patterns a little bit more before you opt to just go and use one of them. Then we have the family of MV star. These are sort of frameworks or solutions which try to borrow from bits and pieces of other patterns. So they could be saying, well, I like this in MVC, I like this in MVP, I like this in MVVM, and so I'm going to mix different bits and pieces of this together. If you haven't heard about it, there's actually a solution called Knockback now, which is a combination of Knockout.js and Backbone. In case anyone was wondering if there are too many MV star frameworks out there, no, there's not. But the idea here is that you have to make sure that if you're going to pick out something, bear in mind what flavor of MV it's actually using. Sometimes framework authors will deliberately say, well, we're using something a little bit like MVC. And you need to make sure that you don't fall into the trap of thinking it is actually using that. Because if you understand MVC, you know that it's actually composed of 3 specific parts. And if their framework doesn't follow that, it can be a little bit more difficult for you to understand how you should be splitting up your application to fit the model that they advocate. The pattern most commonly used these days in our world is MVC, and I put that in quotes for a reason. So these are the solutions that a lot of us are using at the moment. Backbone, Spine, Ember.js. Hands up if you're using any of these right now. So at least half of them are using these. That's cool. So none of these are actually using MVC. All of these are using their own particular version of MV star. Smalltalk 80 was actually the very first language to try implementing MVC, and the guy that did this was the very first person in any language to implement anything like MVC. Now, the idea behind it was to just try separating the presentation logic from all the other stuff going on in your application. And the idea was perhaps that's going to make it a little bit more maintainable. Fun fact, MVC was actually not originally called MVC, it was originally called MVCE, which is Model View Controller Editor. Don't you feel enlightened? So, different languages actually implement MVC very differently. Smalltalk was an object-oriented language. JavaScript and other languages will sometimes try fitting the frameworks that they, when people write things in JavaScript, they'll try fitting it into MVC, and it's not perhaps always the best idea. It's not necessarily a pattern which fits best with the language, but you can actually structure your code in ways which make the best of models and views, and perhaps something a little bit different for the last part. So what is the MVC pattern all about? So we've got models, views, and controllers. Models are used to represent the knowledge in your application. So again, let's go back to a photo gallery. What kind of models are we going to have there? Does anybody want to guess? Photo gallery application, Facebook. What kind of models does Facebook have? Anybody want to guess? Okay. So Facebook's probably going to have a few different types of models. They're going to have models for photographs or media. They're going to have models representing people. They're going to have models representing maybe even tags. But what you want to do with models is take the business-specific data that you're using in your application, break it down into something that can be models. Models also respond to requests for state and requests to change state. So if I'm a view and I'm editing a specific photo that's tied back to a model, I want to know when that model's actually been updated so that I can refresh my view. And models are typically isolated from the views and controllers. In some frameworks, they're grouped. So if you're using Backbone, you probably already know that models are grouped in collections there. Some frameworks do that, others don't. Then we've got views, and in most cases, it's considered the UI. They're typically rendered to specific user interface elements. If you're using Backbone, again, you're probably familiar with L and how to bind particular templates or particular views to specific elements. And multiple views can usually exist for single models. So what does that mean? Well, I can have a concept of a photo in my application once again. And there can be a lot of different metadata associated with that photo. I can have perhaps the location where that photo was taken. I can have the different people that are in the photo. I can have different tags associated with that. And if I wanted, I could have a different view representing and allowing you to see each aspect of this data. Then we've got controllers, and this is where it gets interesting. Most JavaScript MVC frameworks don't actually use controllers the way they should be. The idea behind controllers is that they should be sitting between models and views, and they should be handling all of the user interaction. In many frameworks, what they do is they actually try integrating the controller logic directly inside the view, and that breaks what the MVC pattern is about. It's not to say that it can't work well, but that's not MVC. Again, the controller's role varies quite a lot. Anyone who's been using, again, Backbone for quite some time will know that originally it did come with something called a controller. And with time they realized that they weren't actually using it as a controller. What they were using was something a little bit more akin to a router. And that's why they renamed it a router. And in some MVC implementations, again, they'll have views observing models, meaning that, again, if a model changes, the view updates. So how does this work? If you've been using any structural solutions for a while, this will seem quite obvious to you. This set of slides is really just for people who are perhaps not as familiar with this stuff. But if you've already got like a very long JavaScript file and you're trying to figure out, okay, well, how should I be splitting this up into different concerns? One thing you can do is first of all take a look at the unique data that's represented in your application. Again, so using Facebook as an example, photos, tags, etc. Next thing to do is figure out what is it that in your application the user's going to be able to see. What should be represented in the presentation layer. You also want to take a look at what repeatable output in your application you can shift to JavaScript templating. So one of the problems that we had probably anywhere as far as 8 years ago in the JavaScript world was people would actually be doing a lot of string concatenation in line when they were trying to build up templates. So they define a template for something like the output for an image in a list inline in their JavaScript. And then they try populating that by looping through arrays or looping through whatever data structures they had and generating the entire string for their template in memory there. And then they I've seen people that would actually output using document write every single time that they looped through, which is extremely bad performance-wise. And some people will do something a little bit more sane, which is just appending once. Ideally in JavaScript, if you're using templating, you should only be appending to the document once. If you're refreshing the view and you're working with new data, that's fine. It's fine for you to do other things. But make sure that you're using JavaScript templating where possible here. Then we've got controllers, which should be handling your user interaction. So take a look at your code and see what is it, where are people clicking? How are people interacting with your application? That stuff should be going into the controller. Or controllers. So all JavaScript MVC frameworks interpret MVC a little bit differently. And that's not a bad thing. It's not a bad thing as long as you understand how it is that they're actually breaking these things apart into their own separation of concerns. So I keep mentioning Backbone. Backbone is actually my favorite structural solution on the front end these days. It's extremely lightweight. It's got a lot of other advantages I'll take you through. But if you take a look at this list, what does Backbone's MVC look like? It's models, views, collections, and routers. There's no mention of a controller there. Models in Backbone contain domain-level data, so that's the exact same as MVC or MVP. Your views are still your user interface, but it's a little bit closer to a controller. And not only that, it's closer to the P in MVP than it is to the C in MVC. You then have collections, which are groups of models, and you have routers, which map URLs to functions. Now, as a paradigm, this actually works quite well for us. It's fairly flexible in that if I didn't want to use routers, I can still build an application just using models, views, and collections. If I didn't want to perhaps use collections and I just wanted to have a view, a single model, and a router, I can do that. And that's nice. It's nice having that level of flexibility. But at the same time, when you start building applications which are going to grow, it's important to understand how you're going to end up separating concerns. Will something that perhaps only uses parts of this be a little bit more efficient for you? Now, if you want a good reason for any of this stuff to matter to you, here's a little fun fact. People who are actually committing code to Backbone.js, people who are regular committers to it, don't use Backbone in the way that it's actually documented on the official site. They understand the patterns that I just talked about, and that allows them to actually restructure their Backbone code in such a way that it's perhaps using it in a little bit more of an MVP fashion. That means there's a slightly greater focus on how the user interface is rendered and how you tie back user interaction to it. But that works better for them in their applications because they understand these patterns. Again, why consider Backbone.js? I should probably mention I'm writing a book on Backbone at the moment, which is possibly why there's a lot of Backbone slides. But I love Backbone because it's got a lot of great stuff in there. It's got flexible conventions for structuring applications that I just mentioned. It's got event-driven communication in there. So you can do things like sense and respond to stuff. So if somebody clicks on something in your UI, you can respond to that. You can sense that and you can respond to it very easily. And you can essentially do that for any type of behavior going on in your application. It supports data bindings for people that like NVVM. You can actually do this using manual events, or there are a number of Backbone plugins which let you do that as well, if you don't want to go using Knockback. And it's successfully used by a number of large companies. I can't really stress how important it is for whatever solutions you use for your small to medium-sized applications to be well tested out in the industry. Picking something that's perhaps only been out a few weeks can be exciting, it can be interesting to use, but it's important to pick solutions that have a level of maturity to them, because A, it's going to mean that there's a lot of people in the community that have already tried it out and can help you if you need any assistance. It also means that the documentation for the solution has probably had an opportunity to mature. Backbone's documentation is not the best in the world. Even the people who work in the project acknowledge that. But it's improving, and they're going to keep trying to improve it. It's also important to see how well large companies are able to use these solutions. Because if you're going to be throwing millions and millions of people at an application, you need to be able to structure it in such a way that A, it's going to perform well, B, it's going to scale in such a way that if you want to add new features over the next 5 to 6 years, you can do so in a way which doesn't require a complete restructuring of your entire application. And solutions like Backbone can help that. So here's a very, very small portion of all of the MD Star implementations that are out there: Backbone, Spine, YUL Library, Backbone.js, Broke.js. And for anybody looking for a very quick guide, again, I'm going to try rushing through this because there's a lot more interesting stuff coming up. Backbone is good because it's light, mature, and it's popular. JavaScript MVC, has anyone played around with that at all? No, okay. JavaScript MVC is quite good. One of the problems with it is perhaps that it could use a little bit more documentation, and some people find it a little harder to get started with, but it does include integrated dev tools. So anything that you might find yourself sort of trying to put together, like a build process or so on and so forth, JavaScript MVC already comes with that. Spine is great for people who love CoffeeScript, Spine or Batman. Spine's been around a little bit longer. It's got a slightly smaller core than Backbone does, for anyone that's interested in it. Ember.js has got a Sprout Core 2.0 base, which again means it's quite good for data bindings. And I'm going to mention Sammy.js for anybody that doesn't really care for models or views. Sammy.js provides you sort of a decent route/controller solution. So you're able to sort of capture things like interactions with your user interface and people actually navigating to different routes, but it leaves it up to you to figure out how exactly you want to structure the rest of your application. Which again, if you're into that, it can be useful. For people that are still sort of on the fence about what they should be picking, if you're using Backbone.js at the moment, or you're not even using any of these structural solutions, and you're trying to figure out, okay, well, what should I be learning? What should I be trying out? What is it worth my company or me investing my time in learning? I created a project called To Do MVC, and it tries to help with this problem. So To Do MVC is essentially the exact same application implemented in the vast majority of popular MV Star or MVC solutions that are available at the moment. There's only a very small list of what we currently support: JavaScript MVC, Ember, Spine, Sammy. And one of the cool things about this is that, so it's essentially a to-do application. I'm going to show you a vanilla JavaScript one. I don't know how well that's showing up on the screen. Let me move it over there. Right, so the idea behind a to-do application is I can say, okay, well, attend async, blah, blah, blah. I can enter as many of these in as I want. I can select these. I can say they're done. I can edit them inline. And there are a few other features that these to-do applications basically have. But if you come from a background where you haven't actually been playing around with structural solutions before, and you want to see how you might actually go about converting, let me see if I can make this text a little bigger. Okay. If you want to go about looking at how you might convert vanilla JavaScript to something that breaks down into models, views, and other aspects of backbone, for example, I can first of all take a look at the 2MVC vanilla JS implementation. I can see, okay, well, this is somewhat a concept of a model. But you can go through and say, okay, well, in a vanilla JavaScript implementation, I'd probably be dealing with my event handlers. I'd be dealing with actions in the user interface, which might come under a traditional controller. I then have my presentation layer for how the logic for this application might end up being structured. And then I can actually go to my backbone version of the 2MVC application. Now, on the site for this project, you can easily just go and click through any of these and start browsing the source code. But I think this is better in Netter at the moment. But here I can see, okay, well, this is the model for the same application. I can see the backbone has this idea of having defaults. So if nobody enters anything into a to-do, it's going to have a default event to-do. Done is the current state, so it is an action that's been completed. I have an initializer, I have a toggle, which lets me toggle whether something's actually been completed or not. And I can go through and see some of the other aspects of the backbone. I can see, okay, well, it has this concept of a collection, which we call the to-do list. And it's very easy for beginners to actually go in and see, okay, well, a list is probably going to contain a number of to-do items, right? Which relates to a collection, the whole concept of collection, and I can see how I actually go and structure a collection. And it's just something nice that you can actually go in and start comparing different solutions to. You can do the exact same thing with Ember. If I wanted to compare how Backbone might structure a solution versus Ember, I can do that. The new version of To-Do MVC coming out in a week actually already has a number of other solutions in there. We've got a Dojo MVC implementation as well. So if you've ever sort of considered using Dojo, but you've been sort of afraid of diving into it, you can always just go in and take a look at the To-Do application for it and compare it to what you currently know. We've got jQuery versions of the application, vanilla JavaScript, tons of options for you to just go in and try learning and figuring out if there's a better solution for you.